All right, so basically, instead of 2 pi over b, remember what I told you the period was? It's pi. So if you change this, what happens is it changes the period to whatever pi over the absolute value of b is. So just be careful that period is different on these than sine and cosine. The range is still going to always be all reals. And the domain is going to be all reals except the asymptotes. So we should talk about where the asymptotes happen. So in general, if you wanted to, first of all, if I don't change b at all, that doesn't change the asymptotes. Vertical stretches just change it this way. The only time the asymptotes will change from these odd multiples of pi halves is if there's a b in front. And so in general, to find the new asymptotes when that happens, is we're going to take the old asymptotes and you're going to multiply them by 1 over b, and that's going to be how you find your new ones. And we'll do one together so you see what I mean. All right, there's a tangent function on your calculator, right? Do you see a cotangent one?
Yeah, you for a second.
Yeah, that tan inverse is not the same thing as cotangent. So there is no cotangent function, just like there's no secant or cosecant. So what we're going to do, though, is we know, yes, Leah?
I didn't get the last part. Can you move the paper back up?
Yep. We're going to use the fact that tangent is equal to sine over cosine, and I'm going to show you 2 different ways you can put cotangent in. So cotangent, you can type it in your calculator because it's the reciprocal of tangent. But I want to point out to you, the reciprocal of tangent means that it's this flipped as well, right? So it's also the same thing as taking the cosine of x divided by the sine of x. So those 2 statements mean the same thing. So how would I figure out where cotangent is undefined? Where sine is 0. Where is the sine 0? On the unit circle. We'll put Destiny's up again. Thank you, Destiny. The sine is 0 at the beginning, and then at pi, and then again at 2 pi, and then it's going to be 3 pi and 4 pi and all around. So it's different spots. Let's see what the graph looks like. Don't change your window at all. Would you just go into y equals? We'll take out the 2 tangent. Let's do 1 divided by tan. All right, so what are some things you notice? Yeah, so it looks kind of the same. Like if I would rotate 180, no, not rotate it. It's like flipped over the x-axis, but it's not quite the same because you see the asymptotes aren't not in the same spot. All right, so let's draw our graph. Where should we put the asymptotes? Zero. Somebody tell me where the next one is. Pi. In between the asymptotes, I'm going to use a similar process, except I'm going to make it go be a decreasing function instead. So I have it cross. I still, at the fourths, make it 1 and, but it's flipped, 1 and -1. Okay. So our parent equation we call y equals cotangent x. And even, so sine and cosine are the most familiar of graphing. Tangent is the next most familiar. Cotangent is less even familiar than that. So like again, when we do this today, I really just want you to kind of use this sheet and your graph to kind of picture where asymptotes and stuff are. The domain is all reals except, okay, let's tell, you guys describe the pattern for me. What's the pattern of the asymptotes? Give me a description. Well, it's not just even, I know what you're saying, because we said odd multiples of pi halves. I guess you could say even multiples of pi halves, but isn't this the same as saying every integer, an integer is like a whole number? Integers of pi? Okay. One way that our book writes it is they say pi times k, where k is an integer. Or you can just say integer multiples of pi. And the range is all reals. And the period is same thing. It's pi. Let's, I think it's a better skill to write out the pattern for asymptotes. So the pattern for the equations would be like if I started over here, -2 pi, pi, 0, pi, 2 pi, what would the next one be? Feel a seat change coming on in your near future. It's too noisy in the back. What would the next one be? 3 pi, 4 pi, so being able to develop that pattern. Okay, so kind of the same thing as before. In general, you could have a number in front of the cotangent graph. If you did, that's not called the amplitude, it's just stretching or shrinking it. So the period of this would be pi divided by absolute value of b again. The range is still all reals. The domain is all reals except x is not equal to the asymptotes. And this time, to find a new asymptote, the only thing that would change it is if there's a b there, you would take the old asymptotes, which were just multiples of pi, and once again you'd multiply by 1 over b.